Thank you very much, the organizers, for having me here. I'm a mathematician. My name is Dr. Eknath Ghate, and I work at the Tata Institute of Fundamental Research in Mumbai. I think I might be the. Is this mic on? Can you hear me? I'm going to walk around, do something non-standard. So, I might be the only mathematician in this room, perhaps, maybe in the whole university campus here. Can you hear me? You can hear me? Yeah. So, I thought people say, why don't you get the Nobel Prize in mathematics? And why don't you get this prize and that prize? So let me say a few things. First of all, for us, there's a very simple answer. There's no Nobel Prize in mathematics. So, people don't know this, but my friends still said, oh, congratulations, you got the Bhatnagar Award, please get the Nobel Prize next. I had maybe 200 emails like this, and people still don't know that there's no Nobel Prize in mathematics. So at least that pressure is not there. But there are some other prizes. There's the Fields Medal, and there is the lately instituted Abel Prize, which is supposed to be the equivalent of the Nobel Prize. And actually some Indian people, or people of Indian origin, have actually won both of these things. So you may know that 2 years ago, Manju Bhargava won the Fields Medal, and he was at the Science Congress last year. He's a friend and a collaborator. He wasn't born in India, his father was, and he was born in Canada and moved to the US when he was 2 or 3 years old. And also the Abel Prize has been won by somebody of Indian origin who did his PhD up to his PhD level, maybe even his postdoc level. SRS Vardhan was here up to maybe his early 20s or middle 20s. So perhaps that's some good achievement and some progress. Of course, it would be very nice to have people from India themselves winning these medals. So rather than complain, and there will be beautiful lots of suggestions here today, let me actually do something which is a bit different. I think the biggest problem in India is people just don't do science. So today what I'm going to do is, I think there are a few maybe younger people here. I just thought I'd talk about some mathematics and do some mathematics rather than talking about how it's done and why we should do it and when we're going to do it. And it's always day after tomorrow that we're going to start. Okay, so let me start with, I work in something called number theory. So that's something that you can easily understand because there's properties of numbers and we deal with numbers every day. Everybody here has heard of prime numbers? Yes? If you have not heard of prime numbers, raise your hand. If you have heard of prime numbers, raise your hand. Everybody has heard of prime numbers. So 2, 3, 5, 7, etc. are all prime numbers. This is supposed to be a slightly interactive talk. You can shout out answers. Let me ask you a very simple question. So by the way, you think, okay, prime numbers already very abstract. You know, I was at Princeton last year for a semester and I learned something very interesting. There are these cicadas, they're like grasshoppers, they make a lot of noise. If you walk through a field sometimes, they make a lot of noise. There are these two species of cicadas there that come out of the ground every 13 years, one species, another one every 17 years. Now, people believe there's a reason for this. So these insects, these cicadas know about prime numbers. And the reason is that their predators also have cycles of coming out of the ground. So if they came out at a number like every 12 years, then if their predator came out every 3 years, they'd be eaten up. Or if a predator came out every 4 years, they'd be eaten up. Because 4 divides 12, etc. every 6 years. So they choose these cycles which are not divisible by smaller years. So when you tell, so these insects themselves know about prime numbers. So even though I'm a theoretical person, let me just say that there are many applications to these things, public key cryptography for instance, but I won't get into that now. So there are 2, 3, 5, 7 are prime numbers. Now, let me ask you, are there infinitely many prime numbers or only finitely many prime numbers? How many people think there are infinitely many prime numbers? Raise your hand. Only 7 or 8 or 9 or 10, 15. And how many people think there are only finitely many prime numbers? Nobody. Okay, great. So there are in fact infinitely many prime numbers. And once I was at school and one of my computer science teachers asked me to check not whether there were infinitely many primes, whether there were infinitely many twin primes on a computer and keep generating them. So twin primes are numbers which come in pairs, like 11 and 13, 41 and 43, right? These are twin primes. And then the next day he asked us to find infinitely many triplets of primes, like 3, 5 and 7. They're separated by 2. Find if there are infinitely many triplets of primes. Can someone tell me if there are infinitely many triplets of primes? Yes? No, the answer is no. Did you say yes or no? The answer is no, because if you have a triplet like that, 3 odd numbers consecutive, then one of them will always be divisible by 3, right? So in fact, there will not be infinitely many triplets of primes. There is only one triplet of prime, 3, 5, 7, and 3 is divisible by 3, but that's a prime number. So that's okay. But for twin primes, they occur infinitely often, at least on a computer. Now, what about the prime numbers? They also occur infinitely often. And about 2000 years ago, Euclid gave a very beautiful proof of this. Let me just tell you this proof because, like I said, we're trying to do mathematics here, so there should be one proof in this talk. Suppose there were only finitely many prime numbers. Then, suppose there were only 10 primes. You could multiply them out and add 1 to it. Now, this number, suppose there was the only prime numbers were 2, 3, 5, 7, and 11. Let's say only 5 prime numbers. And you can multiply these 5 numbers out and add 1 to it. Now, this number would not be divisible by 2, right? Because its remainder was 1. It's a 2 times something plus 1. It's not divisible by 3 because it's 2 times 3 times, remainder is 1. It's not divisible by 5, it's not divisible by 7. So, this number is a new prime and this is a contradiction. It's a very simple one-line argument to show that you cannot have a finite list of primes. Because if it stops somewhere, you could multiply all those numbers out and add 1 to it, and that would be a number which would not be divisible by any of these numbers, so it would have to be prime. So, that's a contradiction. Okay, but twin primes are very interesting. These things that come in pairs, 11 and 13, 41 and 43. On a computer, they keep happening. And people don't know if there are infinitely many of them or finitely many of them. Okay, so people know there are infinitely many primes. They know there are definitely finitely many triplets of primes, but twin primes, people don't know if there are infinitely many or finitely many. So, going back from 2,500 years to something that happened 1 or 2 years ago, and this is why I chose this topic. A Chinese mathematician who worked in Subway for a few years, a sandwich serving restaurant, etc., had many temporary jobs. He managed to show that there were infinitely many primes, pairs of primes, which were separated not by 2, but by a gap which was at most 70 million. Now, this is considered huge progress because till now people didn't even know that there were pairs of primes coming separated by some finite gap. Okay, and now that gap has been brought down, not all the way to 2 from 70 million, but down to 246. Okay, so at least we're getting closer and closer to whether there are infinitely many prime numbers, infinitely many twin prime numbers. I'm going to end with one small advertisement. So, my own research is on prime numbers, and the connection is with prime numbers and modular forms. I work in an area which studies these functions called modular forms. You may have heard of Ramanujan, who lived 100 years ago. He studied these functions a lot. And I'm going to give a more technical talk today at IISER Tirupati. It's going to be a 1-hour talk. My slides are somewhere here, but this time is too short to share that with you. So thank you very much, and hope you have a nice day.